Okay, so when we talk reference angles, what we're really talking about is we're saying, okay, hey, you have your full unit circle, right? Full circle, and you can find any of the 6 trig functions for any of these angles, right? And it's a lot easier when you have a unit circle staring at you, correct? Like without a unit circle, if I just randomly said like find the tangent of 7 pi over 6, you might struggle a little bit, right? It might be a little bit harder. And so what we're going to talk today is we're going to talk reference angles. So each of the quadrants, the second, the third, and the fourth, are based off of the first quadrant, right? If you know what the point is in the first quadrant, all the other points follow suit. And so the only difference between them is positives and negatives. And so what we're going to do today is we're going to go over the trig functions again, right? Sine, cosine, tangent, cotangent, cosecant, secant for any possible angle, but we're not going to use the full unit circle. We're only going to use the first quadrant, all right? Does that make sense, kind of what we're doing? So that way, if you know the first quadrant and you can make the first quadrant, then you don't have to worry about the rest of the circle, okay? So reference angles are based off of the triangles that we would make. So for example, there's 4 quadrants. So in Q1, whatever angle you make comes up from the x-axis, right? So in the first quadrant, whatever angle is formed, and here would be the triangle that we would have used, right, to make the actual x and y's, that angle is the same as your reference angle. So in the first quadrant, whatever angle you're given, that's your reference angle, because we're going to reference everything based off the first quadrant. In the second quadrant, that's the one over here, the angle for anything starts at the x-axis on this side and comes around. This would be the angle that they would give you, right? It would start over there and you'd have that angle going that way. Well, the triangle that it's actually based off of is the one that drops down and forms with the x-axis. So this angle in here is what we're going to call our reference angle. And so what's the relationship between the angle that would be given and the reference angle in Q2? What's the relationship there? What do you know about them? When you add them together, they equal 180. So your reference angle in Q2 is 180 minus your angle that they give you. So if they give you the angle of, let's say, 120, 120's reference angle would be 60. And so if you look at your unit circle and you look at the points for 120, the xy for 120 and the xy for 60, they're the exact same except for the positives and negatives, right? I also have them on my unit circle up here. I have them the same color because they're both formed from the 30, 60, 90 triangle, and they're based off the 60-degree angles. This one's based off of coming up this way, where this one was based coming up that way. We're also going to talk radians. So in terms of radians, what would this equation look like? Your reference angle, instead of being 180 minus your actual angle, is pi minus your actual angle. Yeah. Okay. All right, in Q3, you'd have some angle down here. The full angle comes from the positive x-axis, goes all the way around. So that would be your angle there. And then the triangle that everything is based off of comes up to the negative x-axis. And so just the inside of that is what our reference angle would be. That's what our triangle is based off of. Is that going to be the same as last for 270 instead of 180? I wouldn't go based off of 270 because 270 is right here, right? And absolutely nothing is touching 270, is it? No. So instead, this reference angle is going backwards against the actual angle. So what would be a different relationship? I wouldn't do it based off of 270 for sure. Relationship between theta and the reference angle, theta sub r. Yeah, it's going to be based off 180 again, but this time instead of taking 180 and subtracting the angle, you take your angle and subtract 180. It's the reverse. So your reference angle is the actual angle minus 180 degrees. So full angle, right? Full angle, take off the reference angle, you would have exactly 180. So in terms of radians, the reference angle in this case is theta minus pi. All right, and the last quadrant is Q4. So if you have an angle in Q4, it starts at the positive x-axis and goes all the way around the circle. So this would be the angle that they would give you. And then the triangle, the reference triangle, what the x's and the y's are all based off of, that angle is the one inside that triangle there. Notice the triangles always go down or up towards the x-axis. The triangle never makes the triangle with the y-axis, right? Never with y, always with the x. So what's the relationship in that case between theta and your reference angle, your angle and your reference angle? They're going to add up to be 360. So you can think of your reference angle as 360 minus your other angle, because together they add to 360, so you can subtract one from 360 to find the other. And in terms of radians, 360 is actually 2 pi minus theta. All right, so before we get into finding sines, cosine, tangents, all that fun stuff, we're actually going to determine reference angles just in general. So I'm going to give you an angle. I want its reference angle, all right? The nice thing about these formulas is that they're there if you need them, but hopefully you can think about it in terms of the circle itself, and hopefully that'll help. So let's start with 100 degrees. The first thing you have to recognize is what quadrant does 100 degrees live in? Quadrant 2. And so based off of quadrant 2, you're figuring out how much more do you need to get to 180. So how much more do you need? You need 80. So the reference angle for 100 degrees is 80 degrees. Your reference angle should always be in the first quadrant between 0 and 90. All right, 315. What quadrant is 315 in? The fourth one. And at 315, you're trying to get it to 360. So how much do you have to add to get to 360? 45. So this reference angle is 45 degrees. All right, 195. Where does 195 live? What quadrant? The third quadrant, right? Because it's just over 180. And so if you're in the third quadrant, it's how much do you have to take off to get back to 180. So if you're at 195, how much do you have to take off to get to 180? You have to take 15 off. So your goal is you're either trying to turn the number into 180 by either adding a little or taking some off, or you're trying to make it 360 by adding a little. That's kind of the idea here. So 355 is in which quadrant? The fourth quadrant. And so in the fourth quadrant, you're trying to get it to 360. So how much do you have to add to get to 360? 5 degrees. Notice all my numbers so far have been between 0 and 90. Your reference angle will always be between 0 and 90. All right, 260. What quadrant is 260 in? The third quadrant. And so you're going back to 180. So how much do you have to take off to go back to 180? You have to take off 80 to get back to 180. What was that?
Nothing. I was making a joke. I heard my brain registered back to 180 as back to reality.
Oh.
It said that.
You're old school with that song. 245. What quadrant is 245 in? The third. And so in the third quadrant, you're trying to get it back to 180. So how much do you have to take off to get back? 65. What do you think? Yes, no, maybe? How are you feeling about those? Good. Do you want to do some more examples, or are you okay with those so far?
Let's not do the
Let's not, right? But we're going to. All right. In terms of radians, you got to think about them as fractions, all right? That's really the best thing I can do is just think about them in fractions. So please don't pay attention to the pi. They all have pi's, yes? All of their reference angles will have the pi. So there's just going to be a bunch of pi's. Pay attention to the actual fraction itself. So this fraction is 4 over 3. Now in terms of 180 and 2, or not 180, but in terms of, 180 and 360, we're talking about pi and 2 pi. So this is a full pi, right? So this is either 1 over 1, 2 over 2, 3 over 3, 4 over 4, 5 over 5. You see what we're saying? Over here, this would be twice as much on the top in the numerator. So like 2 over 1 or 4 over 2, right? Or maybe 6 over 3, 8 over 4. Whatever you have there is going to divide to make a 2. And so based off of this 4 over 3, is 4 over 3 closer to 1 or is it closer to 2? Closer to 1, right? And so you're going to try to get it close to pi. So how much do you have to take off for 4/3 to become 3/3? 1/3. So your reference angle is pi over 3.
That's magic.
So think about them as fractions, all right? As like chunks of a whole, because the whole pie is here. So we got chunks, right? Chunking it's kind of like a pizza. You got a third of a pizza. All right, 7 pi over 9. So don't focus so much on the pi, right? 7 over 9. Is 7 over 9 closer to 1 or closer to 2? Closer to 1. And how far away from 1 is it? It's 2 over 9 away, right? So its reference angle is 2 pi over 9. How far do you have to add? How much do you have to add or take away to get to either a pi, a full 1, or 2?
So it goes both ways. There's either add or subtract, whichever's closest.
Well, because if you're in Q2, you're going to add, and if you're in Q3, you're subtracting. Yep. So 7 pi over 6, is it closer to 1 or is it closer to 2? Closer to 1. And what do you have to take off to get it back to 1? Because it's a little too much. A pi over 6. Because right now it's 1 too many, so take off 1. All right, 13 over 12, closer to 1 or closer to 2? Thirteen over 12, closer to 1 or closer to 2? Closer to 1, right?
Yep.
Because it's closer to 12 over 12. So how much do you have to take off to get it back to 12 over 12? 1 over 12. So it'll be a pi over 12. All right, 5 pi over 9. Is it closer to 1 or closer to 2? Closer to 1, right? By the way, a lot of these will be closer to 1 because there's 2 quadrants versus just 1 quadrant on the closer to 2. So how far away from a full pi is it? If it's 5 over 9, what do you have to add to get 9 over 9? 4 over 9. Notice that the denominators never changed, did they? That's kind of a nice thing. If it's over 6, then it's over 6. If it's over 3, it's over 3. If it's over 4, it's over 4. What about 13 pi over 18?
Closer to no.
It's closer, 13 over 18. That's not quite 1, right?
Yeah,
13 over 18 is not quite 1. So this is going to be closer to pi. This one's in Q2. And you're going to try to get it to 18 over 18. So what do you have to add to get 18 over 18? 5 18ths.
I guess I read that as 3 over 8.
Yeah. All right. We'll skip 19. Let's go to 20. 7 pi over 4. 7 over 4. Is that closer to 1 or closer to 2? Because you're either looking at 4 over 4 or 8 over 4, right? And that's really close to 8 over 4. And so this 7 pi over 4 is in Q3 down here. Sorry, Q4. I don't know what I'm saying. Q4. And we're trying to get the rest of the way. So what do we have to add to get to 2 pi in this case? You're trying to get it to 8 over 4. So you need to add pi over 4. 35 pi over 18. Is that closer to 1 pi, which would be 18 over 18, or 2 pi, which would be 36 over 18? 2 pi. And so how much do you have to add to get it the rest of the way to 2 pi? Pi over 18. You need just one more. All right, how do you feel about the radians now in terms of the fractions? What questions do you have? Because we're going to jump now to the sines, cosines, tangents, and all that fun stuff. All right. We'll still talk reference angles, but now we're going to evaluate these trig functions. So I have just unit 1, or section 1, quadrant 1. That's what I'm going for. I have just quadrant 1 on the board. And so what we're going to do is we're going to put this away, this full one. So we're only looking at quadrant 1, and we're going to evaluate all of these. Yes, I know that you could just have your full unit circle, right, and evaluate them from your full unit circle. But the whole point of this is to get to the point where you don't need a full unit circle. You only need the first quadrant, okay? So before I put this away, one thing we have to talk about still is the signs. Because remember, we said everything's the same in terms of the points, except for they might be positive or negative, right? Okay, so in the second quadrant, what is negative? The x's are negative, and x's represent cosine. Cosine is negative. What else is negative?
That would make secant negative.
It would make secant negative. Yes, its reciprocal is also negative. What else is negative?
I want to say
Tangent and cotangent, because it's sine over cosine, right? And so if you have a positive divided by negative, you'll have negatives. So everything's negative except for sine and its reciprocal. And the reciprocal of sine is cosecant. So sine and cosecant are positive in the second quadrant. Everything else, literally everything, all the other 4 trig functions are negatives.
I just got a whole lot of questions wrong on the test.
In quadrant 3, what is negative?
Everything.
Not everything, except for tangent, because when you do sine divided by cosine, you'll have a negative divided by negative, which will actually give you a positive. So in Q3 down here, tangent and its reciprocal, cotangent, are the only 2 things that are positive. Everything else will be negative. Which means that in the 4th quadrant, what's going to be our situation for positive? Cosine and secant. Yeah, down in Q4, the cosine and the secant are positive. All right, so with that information, we're going to put this away, and we're going to evaluate all these trig functions, or as much as we can do in the next 15 minutes. I bet we'll get pretty far. You ready? All right, tangent of 150. Let's start with what quadrant 150 is in. The second quadrant. So will tangent be positive or negative? Tangent will be negative because sine and its reciprocal is positive. So we know that this is a negative number. What is the reference angle for tangent? 30. So the value there is the same as the tangent of 30. So going back to our first quadrant, here's 30. Sine over cosine. And when you do 1/2 over the square root of 3 over 2, you're going to get square root of 3 over 3, right? Those are those 2 that we had on the side. Square root of 3 over 3. All right, cosine of 225. Let's start off with where 225 is at, what quadrant? The third. Is cosine going to be positive or negative? Negative, because the only thing is tangent and its reciprocal, right? So this is also a negative. And what is the reference angle for 225? A 45. And so what's the cosine of 45? Square root of 2 over 2. So this value is negative square root of 2 over 2. All right, secant of 120. So what quadrant is 120 in? The second quadrant. Is secant positive or negative in the second quadrant? It's negative because the only things positive are sine and its reciprocal, right? And that's reciprocal of cosine, so it's negative. What reference angle? What angle am I going to reference for this 120? 60. So I'm looking for the secant of 60. So if you go to 60, secant is the reciprocal of cosine. Cosine's 1/2, so secant is 2. So that value is -2. All right, cotangent of 300. 300 is in what quadrant? The fourth, right? It's more than 270, so fourth quadrant. Is cotangent positive or negative in the fourth quadrant? Negative. And what angle are we going to reference? 60. You got to get it to 360, right? So we're going to reference the 60-degree angle, and we're looking for the cotangent of 60. So cotangent is cosine over sine. So 1/2 over square root of 3 over 2, which will be square root of 3 over 3. All right, cotangent of 240. Where's 240 at?
Second quadrant.
Not quite.
That's the right.
The third quadrant, right? It's Q3. And in Q3, is cotangent positive or negative? It's positive. So either you can just leave it and not put anything, or if you want to be like, hey, I know it's a positive, so I'm going to put a plus in there, that's fine too. Up to you. And what angle are we going to reference for 240? How far away from 180 is that? It's 60. So we're going to say cotangent of 60, which we actually just found, didn't we? On the last problem? The cotangent of 60. We said was square root of 3 over 3. So that's the same thing, only positive. All right, cotangent 210. So 210 is in what quadrant? The third quadrant. Cotangent positive or negative in the third quadrant? Positive, so you can put a plus or you can just leave it blank. And then 210, what's our reference angle for 210? 30, going back to 180, right? So 30. So we need the cotangent of 30. So here's 30. Cotangent is cosine over sine. So square root of 3 over 2 over 1/2, which is just square root of 3. By the way, I remember those divisions because if the square root of 3 is on the top, like literally the one on the top, said I was going to bust this out, but if it's the one on the top, then it's square root of 3. If the square root of 3 is in the middle, square root of 3 over 3. So that's how I remember that. All right. Tangent of 330. Where's 330? The fourth quadrant, tangent positive or negative? It is negative. And what angle are we going to reference for 330? 30, because we're trying to get to 360, right? 30 more. So the tangent of 30 is sine over cosine, so the square root of 3 is in the middle there, so it'll be square root of 3 over 3. All right, and the cosine of 135. 135 is in which quadrant? The second one, and is cosine positive or negative in the second quadrant? It is negative. And what's our reference angle? 45. By the way, if the angle ends in a 5, and you're doing these trig functions with the unit circle, you're referencing 45 every time. And so the cosine of 45 is square root of 2 over 2. All right, thoughts so far? How are you feeling? The goal is to be able to do them with only having to make the first quadrant and not having to make the entire circle. So like on the test, when you start it, you can just make your first quadrant and everything's based off of that instead of having to take the time to write out the entire circle. All right, let's talk some radians. 5 pi over 6. What quadrant is 5 pi over 6 in? Is it more than a pi or less than a pi? It's less than a pi. So if it's less than a pi, it's in quadrant 2. And so quadrant 2, secant in Q2 is positive or negative? Negative. And then what's our reference angle for 5 pi over 6? Pi over 6. We needed one more to get to 6 over 6, right? So the secant of pi over 6. Pi over 6. Secant is the reciprocal of cosine, right? Yeah. So when you flip that, you'll have 2 square root of 3 over 3. All right, secant of 4 pi over 3, what quadrant? 4 pi over 3. The third one. It's slightly more than a pi, right? 4 over 3 is more than 3 over 3. So if this is in the third quadrant, is secant positive or negative? Negative. And what's our reference angle? Pi over 3, because you just need to take off 1 pi over 3 to get back, right? And so secant pi over 3 is the reciprocal of cosine. So the reciprocal of a half is just 2. So that one's negative 2. All right, tangent 2 pi over 3. Is that, what quadrant is that one in? 2 pi over 3. It's in the second because 2 over 3 is not quite 3 over 3, right? So didn't make it to the full pi yet. So in Q2, is tangent positive or negative? Negative. And what's our reference angle? Pi over 3. Can I point something out about these reference angles? If it's over 6, your reference angle is pi over 6. If it's over 3, your reference angle is pi over 3. If it's over 3, your reference angle is pi over 3. Because your reference angles are either pi over 6, pi over 4, or pi over 3. Those are your 3 options for reference angles in Q1. That's it. Those are your options. And so if it's over 6, then it's an over 6. Right? If it's over 3, it's over 3. And if it's over 4, it'll be a pi over 4. All right, so tangent of pi over 3 would be sine over cosine. So that puts the square root of 3 on the very, very top, right? Which means that this is the square root of 3. All right, cotangent of 11 pi over 6. What quadrant is that in? That's in the fourth one, right? Because 11 pi over 6 is really close to 12 pi over 6, which would be 2 pi, right? So this is in Q4. In Q4, is it a cotangent positive or negative? It is negative, and your reference angle automatically is pi over 6. Pi over 6.
Did you see it was for 11, it was negative square root of 3 over 3, or
Just square root of 3. Negative square root of 3. All right, so cotangent of pi over 6. Cotangent would be cosine over sine. That's the square root of 3 on the top, right? And so this one is also just negative square root of 3. All right, up next we have 7 pi over 4. What quadrant is 7 pi over 4 in? The fourth, because that's really close to 8 over 4, right? So fourth quadrant, is sine positive or negative in the fourth quadrant? Negative. By the way, you're going to have a lot more negatives most likely because in each quadrant, 4 of them are negative or only 2 of them are positives. And what's our reference angle? Pi over 4 because it's over 4. So sine of pi over 4 is square root of 2 over 2. So this will be negative square root of 2 over 2. All right, cosecant 5 pi over 3. 5 pi over 3 is in what quadrant? Also the fourth, because that's really close to 6 over 3, right? And so cosecant in the fourth quadrant is positive or negative? Negative. And our reference angle will be pi over 3. And so the cosecant of pi over 3, that's the reciprocal of sine. So that's 2 square root of 3 over 3. Because you're reciprocating square root of 3 over 2. So 2 square root of 3 over 3. All right, cotangent 7 pi over 6. What quadrant is 7 pi over 6 in? The third. That's really close to 6 over 6, right? Just a little more. In the third quadrant, is cotangent positive or negative? Positive. And we're going to reference pi over 6. And so cotangent pi over 6 is cosine over sine. That puts the square root of 3 on the top. So it's a positive square root of 3. And last but not least, cotangent of 4 pi over 3. 4 pi over 3 is in what quadrant? The third, and in the third quadrant, cotangent is positive, so you can put a little plus sign there, say, hey, I know it's positive. And your reference angle for 4 pi over 3 is going to be just pi over 3. Whatever the denominator is what you're referencing. And cotangent of pi over 3 is 1/2 over the square root of 3 over 2. And so that one, the square root of 3 is kind of in the middle, so it's square root of 3 over 3.
Nice.
And notice that we had that big unit circle hidden the entire time, right? All right, so your homework is the next 2 pages. I think there's 40 questions, and I want you to do them only using this information, all right? So I know you could do them with the full unit circle. That's what your quiz was on, right? That's what we've been practicing. But the goal is to do it only using the information about Q1 and if things are positive or negative. So this is the information that's important. If I were you, I would take a moment to jot this down real fast or take a picture before you leave of what's going on there, especially with the positives and negatives, because you're going to get home and you're like, oh, shoot, I don't remember which ones are positive or negative and what quadrants. I want you to remember that. So I would take a picture of that or jot it down somewhere. That is going to be the one thing that you will use to help you. And then I will see you on Tuesday, right? Tuesday. Huh? Like a minute and a half, maybe. I don't know, it depends. That one's, I think, a couple minutes early. This is 10:57, so I think you have about a minute plus something. Huh?